Hey guys, tonight's video is a pretty special video because we're going to finally get our tool table built in Fusion 360 and also Mach 3. So I'm going to give that a shot. I have not done this yet, and I think that this is kind of the next step. I've been making some chips and doing random projects using the wizards that are included with Mach 3, but I think without finally integrating the tools, having actual tool numbers with offsets in the system, I don't think we're going to get very far. So anyway, I've been kind of putting this off because it seems like it's going to take a bunch of work, but I don't think it's really that bad. So I'll show you what I'm doing to make it happen, and maybe that will help you guys out if you've been wondering how. Okay, so for tonight's video, there's a couple of things we're going to be using. We've got our height indicator here. For some reason I can't. The name of this is actually slipping my mind. It's a height gauge. Yeah, digital height gauge. So this happens to be a digital one. It's flashing at me. I'm assuming the battery is bad or going bad. Let me swap that really quick and see if that changes anything. That's the bad thing about having digital everything is batteries. I'd say that's the worst part. Cool thing is I found these LR44 batteries on, I think it was Amazon, and I was able to buy 100 pack of these for like, it must have been like $5 or $6 about, I don't know, 8 months ago. I needed some spares for this, so I went on there and I looked for a few, and I found these guys, and I was like, are you kidding me? You could buy 100 pack of these for like a 2-pack of Energizer ones, and it just blew my mind. So let's see if I wasted my money or not. This will be the first test with one of these cheap batteries. Not looking good. Okay, really? You gotta be kidding me. They can't be so cheap to where they don't even work, can they? Wow. That may have something to do with the pricing. Did the stingy man finally get beat? You know, it's funny. So originally I thought this thing was broken. I had bought this thing used on eBay for like $200 a couple years ago, and I got it and it didn't work. And it turns out, like, I took the thing apart, and it turned out that it wasn't broken. It's just extremely sensitive. So if this gets pressed in, it messes with the crystal display, the LCD screen or whatever, and it won't allow it to illuminate. So if you have one of these and you think it's broken, pull on this and see if your screen comes back, because I found that that's the problem I was having. So if you bump it, it may shut off, but it's really just putting pressure on the LCD screen. And I would say that's a flaw of this thing, and you can fix it simply by alleviating some of the pressure by pulling it outward, and it should work pretty flawlessly after that. So currently it's in millimeters. I switched it to inches. It's also now time to crack one Coors Light. It is Labor Day 2016, and I worked my butt off, so this is to all the people out there that have jobs and work their butt off to support other people that aren't interested in having jobs. Okay, so the cheap batteries off Amazon, so far so good. The display is no longer flashing. I'm gonna throw the Energizer one away. That's like $5 a piece, and we've got about 99 of these left. So that's the good news. Okay, so we've got our digital height gauge, which is not required, but I happen to have one. I've also got a manual one, but it's a 24-inch tall one. It's just overkill for most things. And dang, you guys can't even see half of this. Not that you're missing out on much. Okay, back at it. Had to throw a charger on the camera. So I was going over the list of things that I'm going to use to try to figure out my offsets for my different tools. We're going to import into the tool library into Fusion 360. Okay, so got a height gauge. I have the Tormach TTS measurement fixture, which really all this is something that allows you to drop your TTS tool holder into, and you'll have a consistent reading, because this kind of represents the bottom of the TTS 3/4 inch collet that will be inside of your machine, assuming you're using one of those. That collet happens to have a face that's ground flat, unlike most R8 collets, which happens to have kind of a radiused face to it. So the TTS version is flat. This represents that, and so you can zero your device, whatever you're using to measure this with. I don't know if you guys can see that. I'll take a look here in just a second, but I'm going to go ahead and touch down. So I'm going to reset or zero that. See if you guys can see that. I'm not sure if you can see the numbers on here or not, but that's not like super important, I would say. The important thing is that I write it down accurately. I've got some paper here. I'm just going to write tool. I'm going to write down tool number 1. There's a few things we're going to want to consider writing down. One of those things is, what is the tool? So I think that we want to start off with like tool number 1, as, you know, whatever. I think tool 0 is going to be the probe, but I'm not 100% on that yet. But the cool thing is, if we write down all this information, if we ever want to rotate the tool to something else, we'll know, you know, what tool is getting shifted, and we'll have the data written down for it. Now, that being said, if you happen to have, like, this is a 1/4 inch 2-flute end mill here. If I wanted to use this and hold it really stubby so there's not much sticking out to limit my amount of deflection on the tool itself, then I could seat it down there further. But it also kind of screws me if I'm worried about this ER20 collet nut hitting my work, which happened to be last week. So I'm going to go ahead and leave it here with a little more standing out, and just use it like that, and I'll let you guys know if I have any issues with it. Optimally, you'd want to have this chucked down to there if you could, because that's going to eliminate a lot of deflection, which I think will, you know, decrease your tool life and give you a lesser quality surface finish. So for tool 1, which is what I had this labeled with a Sharpie at one point, and I'm going to go ahead and write that again on here using a Sharpie because it's temporary. So just writing 1 on there. Keep this simple. So tool number 1 is a 2-flute. It's a high-speed steel end mill. It is a 1/4 inch. So I'm going to write 250 thou. And then the actual length of the flutes on here, should take a quick measure of those. I'm guessing this is around 3/4. It's actually 5/8, thereabouts. Really. about 650 thousandths. Flutes, 650 thousandths. Okay, so now the actual tool height off the face of the collet, we're zeroed to this TTS tool fixture. We're going to go ahead and bring our height gauge up. Make sure that there's nothing on the tip of the cutter. And I'm going to bring this guy down until we just touch. Okay, we are three inches 274 thousandths. Okay, so offset. I'm gonna create a special little thing here. It just says offset. I don't know if you guys can see that. Probably not. But offset is 3.274 inches. Okay, that's pretty crucial there. That's our big one we want to have right. Otherwise, you're going to cut too deep or too shallow, crash your tool, or some other list of bad things. So tool number 1 is done. Moving on to tool number 2. I don't recall which one of these guys was tool number 2. Oh, here it is. It's a 1/2 inch, or is this 3/8? It looks like 3/8 to me. Trust but verify. Oh, it was 3/8. Okay. All right, so tool number 2. Tool number 2 is a. I started this off. I don't like how I wrote this down the first time, but I can change it up now. It's not too late. So they call it a 3/8 2 flute. Now I'm not going to write down end mill and everything because I know these ones are end mills. So I'm going to keep this simple. Keep the information kind of abbreviated. Flute length on this guy. Let's take a peek here. Take a peek. We have 3/4 inch flutes. Flutes. 0.750. And what is the offset? So since let me make sure you can see this. Since we know we're already zeroed to the TTS holder there, all we have to do is bring this bad boy down till we touch. Okay, so we're 2.970. I'll take a second. Whoa, that's a big difference. 2.969. 2.969. What I'm doing is just going until I get it to actually feel resistance. I'm not scratching it across there, although this is a carbide tip and I don't think that the high-speed steel is going to scratch it. Yeah, so offset is 2.969 inches. That's our verdict after doing our tests. Now that I did it that way, I want to verify tool number 1. Remember when we did that? I didn't test it like 4 or 5 times to make sure I was getting a consistent reading. Shame on me. So let's try that here. Is that tip broken? It is not. That's some type of relief angle built into this. What the? I swear that thing is broken. 2.274. It's exactly what I had before. Okay, but I think I got a chip out of that bastard. 2.274. Okay. So we got tool number 1 and tool number 2 done. Let's move on to tool number 3. Tool number 3 is a chamfer mill. So let's go. Number 3. This is a 1/4 inch. I will verify that. It is a 1/4 inch 2 flute chamfer mill. Flute length, let's get it. This guy, I guess 1.238, we'll call it 1.238. 0.238 inches, and get this guy in here. If you don't have a height gauge, I really think you should get one. They make some inexpensive ones on Fleabay. You can pick them up for about $100. Now the reason I got a twin beam is because this happens to be the type that I used in machinist school. So we've got 3.745. Let's do this just until, yeah, all right, 2 exactly the same. So offset is 3.745, or 3 inches, 745 thousandths. So like I was saying, in the machinist school that I went to for the United States Army, it was in Aberdeen Proving Grounds, Maryland. I went there in 2010. Really good school. I learned how to do manual machining there. They didn't teach any CNC work. I never had a CNC machine until I bought my first Harbor Freight X2. Is the equivalent, I guess, Sieg or Seg or whatever that company is. Harbor Freight sells a micro mill, a little desktop CNC. It's about a size smaller than the Grizzly G0704 that I happen to have 2 of right now. And that little guy, very lightweight, capable of doing some serious hogging apparently if you're Haas, but that guy's taking things to a different level on you know, every machine he touches. So if you haven't, if you don't know who Haas is, you should probably just go to www.g0704.com and check out his site. The guy's very talented and smart, really smart. So we've got tool number 3 done. Now let's go to tool number 4. So this is the basically the Tormach shear hog. Single flute end mill, indexable. So we've got replaceable carbide inserts, and going number 4, we're gonna call this shear hog. That's its name. Doesn't need any other explanation, but I'm gonna call it a single flute. 1 flute. Okay, now this thing is made by AB Tools. So right here you can see this. This was actually before the Tormach shear hog existed. So this has a TTS adapter on it. It has a 3/4 inch shaft, and then it is basically what Tormach is selling on their site now. So you can get these directly from AB Tools, and go to their site, or you can go to Tormach and get one that has this TTS adapter already on there. This one's been pressed on and then epoxied, so it stays put. And this is an actual genuine Tormach TTS tool holder adapter for this guy. So well, there's more that we have to do than just take a look at this. Well, I think it's a 3/4, but I want to do a measure to find that out for sure. All right, let's do the offset and I'll be quiet. I'm sure you're sick of hearing me talk. Oh, ready? We got 2.977, 2.977, 2.977. So if I have two exactly the same from here forward, I'm going to try to limit it to 2 just to save a little time. So we've got 2.977 inches for our offset for this Tormach shear hog. Even though that contradicts what I just said, because I said it wasn't actually a Tormach shear hog, because it's the one direct from AB Tools. But they're who makes it for Tormach. I'll get over it. So let's take a little look here. This should be a 3/4 inch diameter. Yes, 3/4 inch. Okay. Right on. Right on. 3/4 inch shear hog, single flute. I want to make some chips fly with this thing. Okay, and this is labeled tool 4 as shown. Let's open 1 Coors Light because we are past halfway. We're not doing any machining, so this is safe. Okay, now up next we have the Tormach Superfly. All right, so drop this little guy in here. This is tool number 5. I want to make some chips fly with this guy. But I say that about all of them, so no surprise. I'm curious how we're going to find out the diameter of this thing. And this is kind of interesting because it's not just a set diameter. It depends on how deep you cut. Because that is a wedge shape, or whatever you want to describe this as. And the deeper you go, the wider your cut is actually. So, interesting dynamic there if you think about it. I don't know what to call the diameter of this thing. But what I'm going to do is base it off of where the tip currently is and in relationship to the center. So 5, this is the Tormach Superfly, is all we're going to write is Superfly. Superfly 1 flute. And for this next portion, what we can do is, what can we do here? Okay, so here's something we know. We know that we're zeroed off of, okay, we're zeroed to the top of this guy here. So if we touch off right on this part and then divide that number by 2, that gives us this, gives us that diameter. And then we would then check from here to here to see what that is, and then multiply that difference by 2. Yeah. Okay. All right. I'll shut up. I'm going to do some math and we'll figure out if I'm right later. Let me do this. Okay. This is all going to make sense here in just a minute. Okay, so I bet this was supposed to be a 1/2 inch, but it's not. Not that it's super crucial. All right, so we have 1.494, which is the diameter of this, which is cool. We can leave that. And then all we need to do is get the difference between that. I'm going to reset this now. So that's zeroed on there. Now we're going to set this guy up like this. We're going to touch the tallest point of the tip of this cutter. And then the offset of this will need to multiply times 2. And then add it to our 1.494 inches. Right? I think. Okay, I take this back. I'm measuring the outside tip of that. That's wrong. That is completely wrong. Dang. There goes my great idea. I need to go down here to this part of it. Just to that part. Yeah, right there. Okay, so we have 0.613. So if I multiply that 0.613 times 2, we're going to get 1 inch 226 thousandths. 1 inch 226 thousandths. And I add those together. Get 0. Here we get that. 2, 7, 1. 1.720. Are we right? Oh, forgot. All right, sorry. 2.720. Yeah, I bet that's right. I think that's right. Let me do the old eyeball verification. Yeah, because this is a guesstimate right here. I'm about 1.331. Times that by 2. We're going to get 2.662. So that's just a really rough one. Multiply it by 2. Gets us close to that. So my math is accurate enough for the girls we run with. So let's go with that. So the diameter of this then is 2.720 inches. Now we need to get some height offset. Tormach, Superfly. Oh, you know what we need to do? We need to re-zero now because we changed it. Okay, consistent reading twice. I promised that we would call it good at that point. Drop a Superfly for a white guy on there. Tool number 5. What is our tool offset? 1.879. 1.876. Uh-oh. Inconsistent. 1.876. 1.878, 7, 1.877. All right, we're going with that. 1.877. One more time just for giggles. 1.87. Ah, damn. 0.78. All right, we're going to keep doing this until we get a couple consistent ones. 1.877. 1.877. 1.879. I think it's actually 1.879. 1.879. Okay. That would be better than the other way because you can't add material as easy as you can take it away. I'm going with that. That's my final answer for right now. Alright, so tool number 5. Final answer completed. Let's go to tool number 6, which happens to be our spot drill, center drill. Could be a chamfer mill if you wanted it to be, but it's probably not suited for that as well as other things. Okay, all that being said, let's write down tool number 6. I'm going to write center drill, C-E-N-T-R-E, as our European friends would write. And I don't know what else we need there. I don't think it's imperative that we write 2 flutes. I think that maybe we should write down that it's a 5/16 center drill. Yeah, I'll write 5/16 center drill. Although the hole that it makes, I think, is more like 100,000ths of an inch. Let's get that tool offset and I'll shut up. .238, 3.237, 3.238, 3.238. We're going with that. 3.238, 3.238. Okay. Hot dog. Boom. What do you know? I think this is a 1/2 inch drill, as I recall. I'm wrong. This is getting out of hand here. It's 468 thousandths. Tool number 7. It is a 468 thousandths drill. I'm going to put drill bit. Let's get a length on this bad boy. An offset. I'm going to start it at the tip. I know, that's what she said. Okay, 5.536. Let's get a second measure. 5.535. 5.536. I'm going to go with that. 5.536. So let's take a look at our notes so far. See if you guys can see those. So we have 7 tools measured tonight. There's probably better ways to do this, but this is what I was thinking would work out pretty good. And that's what I'm gonna do. So now I'm simply gonna import these into the tool libraries, which I'll make a separate video on that, and I might even take 2 videos because I'm really slow at this. But thanks for watching. Hopefully this helps you kind of understand what the offsets are. Please feel free to comment if you've got any questions, or if you got suggestions. Those are equally as welcome, and appreciate the support. Subscribe and like. We'll talk to you on the next one. Okay, let's do one more tool. This is actually going to be the Heimer 3D taster. So I'm just going to put Heimer 3D, and I don't know what tool number I should make this, so I'm just going to make it tool number 8 for now. And what I'm actually going to do is I'm going to compress this guy until I zero. Man, it's tough to get this absolutely perfect. Let's go. Okay, first one I'm going to write up here, 5.497. Bring it up. Bring it down. .497. What was our rule? We do it twice. It's exact. We call it a day. We don't sit here and bull all night. But we're gonna break that rule. Double check. Yep, 5.497. So 497 thousandths of an inch is where this Heimer actually reads 0. So if you don't have one of these things, these are pretty darn cool because they'll do an X, Y, and Z zeroing, and so you'll lower this to find the height of something. And this Heimer 5.497 inches is where it needs to be to 0. So 5.497 inches, and that's that. Now let me raise this up. I'll show you something else. So not only can it do it in that orientation, but it can also do it from the side. So you see here, and it can go from the other side.